All right. Hi, everyone. This is my STATS147 final project. And in this final project, I just want to explore shell scripting for Git specifically. So the focus of this project is Git and version control. Shell scripting is just a way for us to get there. Let me just introduce my project to you. So what exactly is shell scripting? Shell scripting is the way for humans to interact with the operating system. Right now we have a GUI to interact with our OS. So for instance, I can open up my file explorer here and, open up any files that I want. But back when we didn't have that, people would interact with the operating system using the command line shell. And it's also very useful if you want to perform more nuanced, repetitive, and sort of algorithmic tasks that you might have to write code for. For that, I think a command line shell would be a much better option. Now, Git is a version control system that essentially manages changes to files and directories in a project. This is very useful when you're collaborating in a project and you need to keep track of many different versions of your code. And just for note keeping, I think it's very good practice to keep a record of all the changes that you've made to your files or to anything really in your project. In this project, again, just to reemphasize, we're gonna look at how to use Git to keep track of your code using shell scripting. And again, I just want to emphasize that the primary purpose of this project is to learn Git, and shell scripting is just going to help us get there. Okay, so let's look at how Git works. So I think before we look at how Git works, something very important to understanding Git is that Git works on repositories. Every project basically can be stored in its own repository, right? Now, suppose that you have a repository stored on your local machine, and it's saved as a directory, as a file directory. And let's just say that it's called STATS147-Git, and it stores a file called report.txt, which is a text file, so you can edit it through Notepad. Every time you make a change to this file, Git is going to keep track of these changes. And each time you ask Git for the status, it's going to tell you if these files have been modified. Let's just say you have a birthday card. You write something on a birthday card. Git is going to keep track of whether or not you've written something on that birthday card in comparison to when you last opened it. Now, to save these changes, Git has something called a staging area, right? So essentially, you've made these changes. Well, now you want to save the changes. And that's done by adding your files or adding everything in your file directory to the staging area. Now, if I were to draw the analogy if I were to draw a comparison to a birthday card, adding a file to the staging area is sort of analogous to, well, after you've written something on the birthday card, you're putting it in the envelope and you're ready to ship it. You still haven't shipped it, you're ready to ship it. And that's essentially what adding something to the staging area does. Now, once you've saved your changes, which is equivalent to sort of adding it to the staging area, you can commit these changes. Just go through with these changes or ship the birthday card. And in order to do that, you're going to have to use the command git commit. And every time you do make a commit, you will have to write a commit message, which basically is a short, it's a short script or a short piece of text that you write describing the change that you've made or how you've modified your file. And essentially, once you're committing a change, you've updated the version of your file that's on your machine. So again, the three steps are: you first modify something, then you add it to the staging area, which means that, okay, well, these are the changes that I potentially want to go through with. And once you've added it to the staging area, well, you commit those changes, and those changes will then reflect in your file. I think perhaps a better way to think about this is by looking at an image. The image here, this is from DataCamp, and it has a file called report.md. And any change that you make, you can add it to the staging area, right? And the way staging area works, it can work in steps. So let's just say I add one line to report.md. Then I can add it to the staging area. After that, let's say I add another line, right? So that the second line that I've added is not really saved. So then I can again add it to the staging area over here. So yeah, you can add a file to the staging area multiple times. And once you've staged it, once you've added it to the staging area, you can then commit those changes, and then there's a permanent change to your file. That's how. So this is essentially the basic workflow of Git. And this is the first section that I sort of wanted to convey to you. Now, I think a good idea would be to show you a demo, right? So I've already created a GitHub repository, and we'll talk about GitHub a little bit more. But yeah, I've created this repository on GitHub, and I sort of create a clone of that repository on my local machine, which means that I can access this repository as a local directory on my machine, and that allows me to sort of use the command line to interact with this repository. So on a Windows machine, I'm going to have to use git bash to interact with the repository. So right now I'm in my home or root directory, right? I can then use the command cd STATS147 git, which basically cd stands for current directory, which basically means that, okay, I want to change my current directory to STATS147 git. And we're in that directory now. Now, let's just look at the contents of this directory. For that, we use ls. And okay, it has two files called report.txt and todo.txt. We can use git status to get a status report, I guess, on our repository. Git status. Okay, there's nothing to commit, so it seems like there have been no changes made at all. Sorry, there have been changes, but they haven't committed before. So there's no changes that we need to commit. Let's say we want to make a change to report.txt. So to do that, again, we use nano, the command nano report.txt. Okay, so here we are in this sort of text file. Okay, we have not learned the following: how to commit changes, check repositories history. We haven't learned that yet, but that's fine. I don't think that matters. Let's just say I'm having fun delivering this presentation, right? So now I'm just going to save my changes using Control-O, and then I'm going to exit the file using Control-X. Okay, so now I've made a change. Let me just look at Git status. So Git is very smart. It keeps track of all the changes that I've made. Right. Aha, here. It says, well, I've modified report.txt, and no changes have been added to commit. So now the first thing that I need to do is I need to add this file report.txt to the staging area. The way I do that is I say git add report.txt. Yep, it's added to the staging area, and I'm going to say git commit m. Dash m means I'm going to write a message. Added a line about about having fun. All right, there we are, and then that's going to run. Yeah, that's it. So our changes have now been registered with Git. We look at status just to make sure. Yeah, there's nothing more to commit. We've effectively changed our file through this command line interface, and we can probably just check report.txt and see that those changes have gone through. Yeah, they've gone through. I'm having I forgot to write fun. I'm having delivering this presentation. Yeah. So those changes are made. So that was just sort of an introduction into Git and what the basic workflow. So you need to, just to recap, you essentially need to look at the status, check for any sort of like commits or changes that have been made. If those changes have not been staged or saved, you have to add those files to the staging area. Once you've added them to the staging area, you then have to commit those changes. And that's sort of like a permanent change that you make to your repository. The next topic is, can you view a repository's history? So notice that every time we made a change, Git sort of kept track of the files that were modified. So even if I just opened report.txt and made a change to it or added a line, Git knew that I'd made a change. So Git keeps track of everything. And every time we commit a change or type a commit command, Git keeps track of that too. So in essence, you can think of the commit statement as this sort of version update, where every time you commit a change, you're sort of updating the version of your file, and Git keeps track of that. So to have a look at all of the versions or the commits that you've made, you can use git log. So this is the first commit that was made. This is the most recent commit that I made before starting the presentation, and you can just notice that like every commit has some information about it. So it says this is a commit, and this is basically called a hash. A hash is essentially 40 digits long, and it's a hexadecimal string, and it uniquely identifies every commit that you make. You can also sort of look at the difference or the changes that have been made from one commit to another. The most recent commit that you've made can be accessed through a shortcut called head. So if you'd want to look at the difference between the most recent commit you've made and a certain commit, let's just say that starts with C232A, you can use the git git diff command. Yeah, so let me just show you a demo for looking at the history of our repository, I guess. So let's go here, and yeah, let me just add a few lines so you can just see better. Okay, so let's say git log. Right, okay, so clearly there's many there's sort of been many commits that are made, and every commit is identified by a hash. Now let's just say I want to zoom into one particular commit. Let's just say I want to look at this one, the first commit that I've ever made on this repository. I can use just the first 6 digits of the hash to just show that commit. So it's git show. Let me just make sure my syntax is right. Git show, yeah. So git show CA232A, and yeah, it just shows me the first the first commit that I made, and it seems like in this first commit I added a new file called report.txt, and I wrote these 2 lines. So if you look at the commit in more detail, you'll notice here it says A report.txt and B report.txt. So that's just the way of denoting version 1 and version 2, how they've changed. New file mode tells you over here that a new file was created. Index, this is basically a way for Git to sort of store the commit in its memory, so we don't need to pay attention to that. That's something that's abstracted to Git and what it does. And these plus signs over here mean that I've added something to the file. Now, if you notice the double add symbol here, these are basically pairs of lines. So this is the pair of lines 0, 0, and this is the pair of line 1, 3. 0, 0 essentially means that, well, I didn't have a file before. So I essentially created a file, and that before I created the file, it had 0 lines, right? And once I created the file, I started at line 1. So notice the plus sign. I started at line 1, and then I added 3 lines after that. So I started at line 1 here, created this one line, created another line, and created this one. And that's essentially what this commit did. And we got a sort of a detailed insight into what happened for that particular commit. Let's just say we want to look at the difference between this commit and this commit. We can just use git diff. So let me again, create some more. I hope you can see the bottom of my screen is right here. Just just pay attention to that. Git diff ca232a dot what's the other commit? Yeah, okay, 667b 69f. Here, so we're looking at the first 6 digits. Yeah. Oh, fate. Oh, okay, yeah. I used oh, okay, yeah. I think I typed the number wrong. Let me just do that again. Git diff ca232a dot 667b 69. Yeah. Okay. So this basically tells us the difference between the two commits. So it seems like in the second commit, I added 2 more lines. So notice that before the commit, at line 1, I had 3. Starting at line 1, I had 3 lines. It seems like at the end of the commit, starting at line 1, I had 5 lines. And in green, it basically shows us here with the plus signs that I added this line, and this line. So yeah, that basically shows us that we can look at a repository's history. We can get a list of the commits, and we can also see the difference between 2 individual commits. Let's move on. Okay. Another big question with repositories is whether we can undo our changes. Suppose we haven't added our file to the staging area yet, which means that we haven't really saved the changes that we want to make. Then it's actually pretty easy to restore our file, and that can be done with git checkout. But you've got to be very careful with it, because this command will essentially discard all the changes that have not been staged. So if those changes are gone for good. So you just need to make sure that when you're doing it, you actually intend to remove all of your changes. Well, let's just say you've gone a step further and you're at the point where you've basically added your files to the staging area. So this would mean that, well, you've saved the changes. The way to go about undoing the change in this case is that you'll have to first remove the file from the staging area, and that can be done using git reset. And it just unstages everything from the repository in the repository. Once the file has been unstaged, then you can use git checkout that we looked at in the first bullet point to sort of discard those changes. Let's just say you've committed your changes. Is there a way for you to sort of go back to a previous version of your repository? There definitely is. You'll have to look up the hash number of the commit that you want to restore back to, and that can be done using git log. And then you can just use git checkout and then the hash number that you want to go back to, and this will take you to the file version when that commit was made. That's essentially what's going to happen. So I think I should give you guys a demo on how to do that. Right. Okay. Yeah. Here. Let me restart a new session so it's easier for you guys to see. And it's at the very beginning of, okay. Okay, let's just make a change to, I guess, report.txt. We can add another line over here. So this change is going to be deleted. Right, okay, we're gonna save the file and we're gonna exit it. Okay, now look at git status. Yeah, git status tells us that we haven't really added this file to our staging area. So I think we're in a very good spot to just use git checkout. And git checkout basically, let me just make sure my my syntax is right. Yeah, git checkout. Now we're going to do report.txt. Yeah, okay, perfect. Now let's look at git status. Yeah, so if you look at git status after that, after we use checkout, we essentially got rid of the changes that we'd made to our report.txt, and all of those changes were gone. And git status now says, well, hey, there are no more changes. There are no changes that I need to record. And just to confirm, let me just look at what report.txt contains. So cat report.txt. Yeah. See, the line that we added, this is going to be deleted, is gone because we used the git checkout command. Now let's just make a change to the file and then add it to the staging area, and then we're going to see how do we undo that that change. Okay. Yeah, okay. So nano report.txt, we open it up and then we say, I want to delete this comment. Yeah, okay, save it. I think it's just it's wilding out here. Let me just make sure that it yeah, okay, let's go. Okay, so we're out now. Let me just check that we've made a change to our file. Yeah, we have. We're gonna add it to the staging area using git add. Now we're going to commit a change and created new version to undo change. Yes, you can do that. Okay, now that we've made a commit now. Now, is there a way for us to go back once we've committed? So the last commit that we made, the most recent one, is okay. We created a new version to undo change. We want to go back to before this commit was made, so we want to go back to basically this stage, right? We want to go back to here, and that can be done by using git checkout. So git checkout, and this is the first 6 digits, 869, 86E, 869, 86E, 869, 869, 86E. Yeah, okay. We've gone back to that commit now. We've gone back. I guess we've turned back time, and let's look at git status. And yeah, we're here now. Let me just look at cat report.txt. Oh, okay. Interesting. Okay, I don't know why this is not working. Let me figure it out real quick. That's it. You can look around, make experimental changes. Oh, okay. My bad. I need to go back to the old one. So here. Oh three bad. I'm just gonna go back to the main, and then I'm going to get. Okay. Now I'm going to check out to the most recent one, which is 203 bad. Now we're back at that point of your that version of your project. So if we do cat report.txt here, yeah, so that line about delivering is now gone. But yeah, we've basically turned back time into going back to our older version. Now, I think the final topic for Git is branches, right? So branches are basically like it's like a parallel universe on Git. They allow you to have multiple versions of your work simultaneously. If you do work in one branch, it's not going to affect your work in the other branch. If you commit a change in, let's just say, a certain branch, that change is not going to be reflected at all. In fact, forget commits. Editing a line in one branch will not, edit the same line of the file in another branch. When you open Git, the default branch that you're working with, that's the main branch. So by default, Git puts us in the main branch. To list all the branches in your repository, you can use the command git branch, and the branch that you're currently in will have an asterisk sign next to it. To show the difference between two files, you can use the git diff command with the name of the first branch, 2 dots, name of the second branch. And if you want to create your own new branch, you can use git checkout, and you'd use -v to indicate that you're creating a new branch, and type the name of the branch that you want to create. Once you've created that new branch, you can then switch out to that branch using git checkout and type the name of the branch. Another way to switch branches is to literally type git switch and then the name of your new branch. You can definitely merge two branches, which is basically saying that, okay, I've made changes in one branch. Now I want all of these changes in this one branch to reflect in that branch as well. And the way merging works in GitHub is you merge one branch, which is called the source branch, into the destination branch. And this will essentially incorporate all the changes that were made in the source branch into the destination branch. Merge conflicts can also occur. Merge conflicts generally occur when either you've edited the same line in two files in two different branches, or you've deleted one file in one branch, and so that file it no longer exists in that branch, but in the other branch it still exists and you've edited it. In that case, there's going to be a merge conflict, and that's sort of that's out of scope for this project, but I just wanted to put it out there that it's not always that easy to just merge two branches. So let me just give you a quick demo of merging branches. So let's see. Okay, you know what? I'm gonna restart again because I like starting at the top of the screen. Git bash. Okay. Yeah. So let me go to my Git repository. Here. Okay. Oh, it's still at the sort of old version that we sort of restored to. I'm going to come back to reality and I'm going to say git switch back to my main. And generally by default, it is at the main branch, but because last time we wanted to sort of go back to the old version, it was still stuck there. Now let's just list the branches that we have, to be honest. Okay, so we have main, side, and update. The asterisk tells us that we're in the main branch. Let's we can switch to the side branch, and this can be done using git switch or git checkout. I'm going to use git switch side. Yeah, now notice we're in the side branch. Let me see what's in the side branch. Okay, we have report and .txt. Let's see what report.txt has. Oh, report.txt. Cat. Oh, I don't know. I can't type today. Here. Oh, okay. So it clearly doesn't have, you know, it doesn't have a few things from our main branch. Let's try and merge the main branch into the side branch. Let's get a little funky out here. So we can, so the main branch is going to be our source branch, and our side branch is going to be our destination branch. Let's see how that goes through. Yep. Okay. So now we've merged the main branch into the side branch. So both these branches are going to have the same version of the file report.txt. And we're assuming that that was the only difference. I also know that there's another file called todo.txt, but we're just going to ignore that for now. And we're just assuming that the only difference in the two branches is due to report.txt. And obviously you could find that out using git diff. But again, after we merged our two branches, it told us that there was only one file that was changed. So now, you know what, I'm in the side branch. Let me just see what report.txt is like. Yeah, okay, so it's exactly the same as the main branch. You remember we'd made these changes a few minutes ago, and we're back at these. We're back in the same version in the side branch as well. Let me actually check the update branch and see what's up there. Okay, let's look at cat report.txt. Okay, cat report.txt. Okay, yeah, see, it's still different. So essentially every branch stores its own version of your file, and you can always decide to merge certain branches into other ones. Just remember that all the changes from your source file are incorporated into your destination file and not the other way around. But yeah, that was basically branches and merging branches. And we're at the end of the presentation. This is basically using shell scripting and Git interacting with Git through the command line interface. And just to sort of give you a little context before we end, GitHub is actually built on Git. GitHub is a graphical interface that essentially does everything that we did in the command line interface, but you can just do it by clicking buttons. And it's just easier to work with Git. But for more nuanced commands that you might want to type in, we always just use the command line interface. And these are the bare bones of how GitHub works. But yes, thank you so much for listening. This was my final presentation.